Okay, and lastly, we have two problems from chapter 7. So example 4, we've got the following exponential function, and this guy is an exponential growth function because our b value is greater than 1. So we are going to continue to increase as we move from left to right, which is why we have exponential growth. So we want to graph it, and we do so using our transformations. So we think about our parent function, y equals 3 to the x, and that tells us what we're plugging in for x, which will always be -1, 0, and 1. Really, that tells us what we're getting for y. So as we're plugging in -1, 0, and 1 into our parent function, we are getting 1/3, 1, and 3. From here, we need to apply our transformations. So this 6 out front is going to cause a vertical stretch by a factor of 6. So we take each of our y coordinates and multiply by 6 first before we worry about that +1. They are both y coordinate transformations, but we have to do multiplication first. So taking 6 times 1/3, we get 2. 6 times 1 is 6. 6 times 3 is 18. Then we've got this horizontal translation to the right one whenever we see that x minus 1. So we take each of our x coordinates and we add 1. So we got 0, 1, and 2. So we've now done away with those. And lastly, we've got this vertical translation up 1 that we have at the end. So we've got 3, 7, and 19. We can go ahead and plot these points. We'll count our y-axis by 2s, and our x-axis can just be by 1s. We've got the points 0, 3, 1, 7, and 2, 19. Now, before you connect your points, consider your horizontal asymptote. We are going to have one at y equals k. So for us, y equals 1. We connect those with a smooth curve that levels off towards a horizontal asymptote as we move to the left and continues to increase as we go to the right. Now we think about our domain and range. Domain for exponential functions is always all real numbers, and our range is always related to our k value. So for us, y is greater than 1. And number 5. So we have a collector's edition toy. It was purchased for $55 in 1990. But then we notice that it loses value, and it loses 2.5% each year, which tells us that our rate, no matter which formula we're going to use, and we'll talk about which one in a second, is going to be 0.025. So since we are just dealing with exponential decay, we are not talking about compound interest. We don't need to worry about our y equals a times, there we go, this one, sorry. We don't need to use our compound interest formula. We only need to use our general growth or decay model. Now, since we are dealing with decay because it's losing value, we are just going to make sure that we are going to take 1 minus that rate in our parentheses. So we have y equals a, where a is your initial amount, times 1 minus your rate raised to the t power. So first of all, we can simplify 1 minus 0.025. So we have 55 times 0.985. That's all right, 975. Up to the t power. Now, if we are asked how much it's worth in 1997, remember that is 7 years since we initially started keeping track of this particular toy. So we are going to plug in t equals 7. And this is something we would want to plug in directly into our calculator. You can either enter it in all at once, or if you want to be safe, take 0.975 to the 7th power, hit enter, take that times 55. Either way, we end up finding, I had it written down, which is at $46.07. Okay, and then lastly, when does it become worth less than $20? Now, this is one that we would need to use our graphing calculator for. We are going to enter in this function for our y equals, and we notice that it starts to decrease. Now, as you increase your windows, you'll see a better picture of your graph. And I would go ahead and plug in as well. So that'll be your Y1. We'll plug in a Y2 equals just $20. And extend your windows out far enough that you can see where those 2 points intersect. They end up intersecting pretty close out to 40-ish. Now, it's not perfect and it's around there, but it's around 40, let's see, about 20-ish. Again, very estimated point. That is not precise, but it's good enough for our situation where we want to know, oh, it's about 40 years later that it is worth less than $20.